Okay, so final exercise for this week, we're going to start looking at solving equations with algebra. We're going to start off relatively straightforward with the types of questions that you've perhaps seen already lower down the school. So the command word changes a little bit in these questions. It says solve. Rather than the words simplify or factorise and simplify, it does ask you to solve. So that means that we should end up with a numerical value for x. So let's get started. So if you have a look at this question, one of the big issues that you'd probably have looking at it initially, one of the things I'd find tricky with it, is this x here. This x here is at the bottom of a fraction, it's a denominator. So that's creating a bit of an issue because I can't move anything from the top of the fraction until I've removed that denominator, because everything at the moment there is being divided by x. Now you can't just go through and cancel out this x with this x. That doesn't work because you've still got the 1 here, which is over x. And so try not to do any crazy algebra, and I'll show you what you should be doing instead. If I want to get rid of that x, the easiest thing to do is to multiply both sides by x. If I multiply both sides by x, times in something by x and then dividing it by x, that's the same as if you thought of a number, timesed it by 2, then divided it by 2, you'd get back to the number that you had. So if I times that by x and divide it by x, on that side now I'll be left with just the 3x plus 1. And on this side here, 11 times by x gives me 11x. Now I want to try and get all of my numbers on one side and the algebraic terms, the x's, which do have numbers attached to them, on the other side. I could, at this point, subtract 11x from both sides, but I don't really like doing that because it means I'll end up with a negative number, and I'd rather avoid negative numbers. I prefer to not have them if I can. So instead what I'm going to do is subtract 3x from both sides, and that means I'm left with 1 equals, because obviously they've cancelled, and then 11 take away the 3 is 8x. Now at this point, if you say that 4 is equal to 2 times by 2, you are also allowed to say 2 times by 2 is equal to 4. So if at this point you prefer to have your x's on the right hand side, you can still do that if you would like. I still haven't got an expression or solved it for just x. I've got an 8 in front of it at the moment. 8x means that it's getting multiplied by 8, and so the opposite of that is to divide. So we've got x is equal to 1 divided by 8, or an 8. And that is our final answer and the solution to this equation. Okay then, here is something that's going to end up with a much more challenging equation to solve. So start as we were. I'm going to put my lines down the side to show what I'm doing as I'm going through. So x plus 1 is equal to 18 over x minus 2. We're being asked to solve it. Like I said before, really don't like having fractions in these equations, and so try to get rid of your denominator. My denominator here is x minus 2, so if I multiply by x minus 2 on this side, and multiply by x minus 2 on this side also, then I should be able to cancel it out. Dividing by x minus 2 and then timesing by x minus 2, that means that on this side all I'm going to be left with now is 18. On this side though, now be careful, I have x plus 1, and when I multiply it by x minus 2, I do have to write it out as a bracket times by a bracket. That will hopefully be a little bit familiar to you, because we do that when we are working with quadratics. So on the side you might just want to do your table. So x and minus 2. So I've got x squared plus an x, subtract 2x, and then overall there is subtract 2. So on that side I'll get x squared minus an x minus 2. So x squared minus x minus 2 is equal to 18. Now, in terms of solving this, we don't normally solve quadratics when they're equivalent to a number. What we normally do is we solve it when it's equals to 0. To get it to be equal to 0, I would need to subtract 18 from both sides. So on the left-hand side now, I'll get x squared minus x minus 20, because I had minus 2 when I'm subtracting another 18. And now I've got it equivalent to 0. To solve that now, I would need to factorise it, which means putting in the brackets. So I'll have x and x. I need to think of two numbers which multiply to give me 20 and then add to give me minus 1. So to get 20, I've got 1 times by 20, 2 times by 10, 3 doesn't go into it, 4 times by 5. Now that looks quite good because overall in the middle I've got a minus 1, and that is a minus 20, which means that one of them was positive and one of them was negative for them to multiply to give me a negative 20. For it to be minus 1 overall, that means I must have had a positive 4 and a negative 5. 4 adding on negative 5 would give me that negative 1. So plus 4, subtract 5. That's not quite the final answer yet though. This means that x, if that bracket had to be equivalent to 0, because it's the only way we get an answer of 0 is by multiplying something with 0, then x must have been negative 4. Negative 4 plus 4 is 0. Or if it was in this bracket here, if I needed this bracket to be equivalent to 0, then x must have been equal to 5. So that's our final answer. X is equal to negative 4 or x is equal to 5. Again, there are videos on that factorising process for you to watch on my channel if you need any more help with that.